One other thing we can think about with noise is where is it coming from? And so, we talk about these as random fluctuations, but there are different kinds of noise, and how you deal with them will depend on what type of noise you have. So this is our final slide. There are 3 different types of noise that we can consider, and sort of what they look like if we plot, how big the noise is as a function of the frequency we're measuring at. So like the laser frequency, or this could be how often we do measurements. We can see there's different kinds of noise. So white noise, or Gaussian noise, is not frequency dependent, and it's just sort of constant across the frequency range. And so these are things that are truly just random fluctuations that we can't really control. 1 over f noise is the type of noise that we're most commonly, or is one of the types of noise we're commonly dealing with. This is also known as drift, and this is if we measure things at very low frequencies, or we have a large amount of noise and it decreases, so it's inversely proportional to the frequency. So as you go to higher frequencies, you get less noise. And so for this reason, there are techniques where you measure things specifically at higher frequencies to get rid of this 1 over f noise as much as you can. And this is often caused by those same things I talked about in the previous slides, slow changes in experimental conditions like temperature and pressure and things like that. The final type of noise is line noise. And these, you have spikes in your noise at specific frequencies, and these are caused by very specific things. So for example, there's a 60 hertz line voltage, so from power outlets. And so we often try to avoid measurements that happen at a rate of 60 hertz because you get extra noise in the measurement due to your electrical equipment. And so that's just the frequency at which power is transmitted through the standard frequency power is transmitted through electrical circuits in like buildings and houses and things like that. You can also have vibrations at specific frequencies from, say, a vacuum pump or something that's part of your system. And there's some mechanical thing in it that vibrates at a certain frequency, and that'll show up as noise in your instrument, for example. And so these line noise, you can often get rid of this by eliminating the source, right? If you can get rid of the source, or you can often spot that specific interference and try and get rid of it, either through signal filtering or by getting rid of the actual physical thing itself somehow. So that is, the techniques we're going to use to deal with noise will vary depending on what type of noise it is we're dealing with. And you're often dealing with all 3 of these at the same time. So it's not like you only get one or the other. These are all happening simultaneously. And so, besides averaging, there are other ways to try and deal with noise too that we've talked about.